In my bag here, I have some chocolate bars. A third are Pinkies, a third are Mars, and a third are Crunchy. I should have put capital letters, sorry. And assume there are hundreds, so that if I changed my mind since I wrote the notes. I've got some here to give you your prizes out of, but so that I don't change the probabilities in here. So 1/3 Pinkies, 1/3 Mars, 1/3 Crunchy. Okay, does anyone want one of those? Anyone want one? Okay, go with the stripes. Which one? What will you guess? I'll draw one at random. Okay, I'll get it now. Okay, what do you think it is? Oh, sorry, no, it's a Pinky. I'll put it back in. Okay, somebody else? Okay, what do you think I've got? Crunchy? Oh, no, sorry, it's a Pinky. Yep. Okay. Oh, no, it's a Pinky. Okay, yep. Pinky. Anyone else? What do you think?
I'll go with Pinky.
There you go. Anyone else want to guess?
Pinky.
What was it? Pinky? I didn't even look. Okay, and the reason I didn't even look is because they're all Pinkies. I lied. Okay? Now, I noticed about after the third one, you laughed because it seemed odd that you were getting so many Pinkies. Okay? Did anybody start to suspect that I might have rigged the bag? Put up your hands if you did. Okay. When? How many did it take before you thought, I think there are too many Pinkies there? How many do you reckon? The third one, you're starting to get a little bit suspicious? You thought it for, you thought, oh, I wonder if she's put anything else in there. Okay, well, I can actually tell you the probabilities of that. Okay, so the probability of one Pinky on the first one, can anyone tell me what was the probability? If I had told the truth, what would be the probability that the first one was a Pinky? 1/3, okay? What's the probability that the first two were Pinkies? Does anyone know? It's the probability the first one was a Pinky was a third, probability the second one was a Pinky was a third, you multiply them, so it comes to 1/9. So there's 1/9 chance that the first two were both Pinkies. Okay, the probability of 3 Pinkies, what do you think? It's 1/27, which equals 0.037. So there was nearly a 4% chance that you would get 3 Pinkies in a row if this was actually true. Okay, so probability of 4 equals 1/81, which equals 0.01235, and the probability of 5 equals 1/729, which equals 0.00137. So I'm guessing by 5 you were pretty much all sure that there was not 1/3 Pinkies in there. Okay, could you be sure that they were all Pinkies? You reckon no? Why not? You're right, you're absolutely right, we can't. The only way we can be sure that that was 100% Pinkies is to tip out the whole bag and look at them. And in a population, you can't generally do that. If I had kept taking them out one at a time and putting them back in, taking them out, putting them back in, I could have gone on pretty much an infinite number of times, and you still could not guarantee that there was only Pinkies in there. Because there could have been one Mars one in there, and it just never got picked. So what we're talking about in hypothesis testing is that we can prove that something is false. So, I mean, if I said it's all Pinkies and I drew out a Crunchy, you'd automatically say, well, that's wrong. So it was easy to prove that it was false, that it was all Pinkies. But you couldn't actually prove that it wasn't 1/3 Pinkies until we got to a certain amount of evidence. And even then, you're only a certain amount sure, because there was one chance in 729 that I could draw 5 Pinkies in a row if, in fact, it was 1/3 Pinkies. Okay, we'll do another one. I've got another bag of chocolate bars. From a free bag I got in the San Francisco airport. Okay, it's got 1/3 Pinkies, 1/3 Mars, and 1/3 Crunchy, and I'm guessing you don't trust me quite so much anymore. Okay, does anyone who would like to have a chocolate bar? Okay, what do you think it's got? Pardon? Mars? Oh, it's a Crunchy. Sorry. Okay, somebody else? crunchy. Okay. Yeah, because she's wise to me. Oh, it is a crunchy. There you go. I'll put another crunchy back in to make up for that one. Anyone else? Now, what do you think? Crunchy. Oh, there's a crunchy. Right, sorry, my shot's not very good. Okay. Yep, what do you reckon? Oh, crunchy. No, sorry, don't get that one. Okay, yep. Crunchy. Oh, crap. Okay, well, that's interesting. There you go. Oh, hang on. Yep. Okay. Yep. What do you reckon? Person, crunchy. I'm actually going to... Yes, a Mars. Oh, no, you don't get one. Okay. So, how many of you thought there was going to be all crunchies? Yeah, but we just proved that that's not the case. But what have we noticed as well? There's no pinkies so far, eh? Okay, nobody's actually guessed a pinky, have they? Anyone else want to try one? What would you guess? Pardon? Crunchy. Yeah, it is a crunchy. Maybe crunchies are easier to feel. Maybe they stick out more or something. Because, in fact, this bag has half crunchies and half Mars. It doesn't have any pinkies in it at all. Okay. So you could still tell that I probably hadn't told the truth. I certainly hadn't told the truth about the pinkies. And so how many did it take before you were suspicious? It took a bit longer, but you were more suspicious because you knew that I didn't necessarily. So the probability of not a pinky was 2/3, so it was 0.667. And then the probability of 2 not pinkies. So in fact, to be reasonably sure that there were no pinkies in there, we'd actually have to take out 11 before we really were pretty sure there were no pinkies. But even then, we're not absolutely sure because there could have been one in there. But it's just that generally, we're pretty sure. And this is the idea of the p-value. So for the rest of your life, when you're talking about a p-value, you can think about the pinkies and the Mars bars and the crunchies. And I'll give these to Troy Van, by the way, and anyone who passes quizzes can have one of these today until they're gone. Otherwise, I'll eat them, and that's really bad. So when we get to 11, we decide that that constitutes enough evidence.